There you go. All right, let me draw a lever arm again. So what we learned when we learned about torque is that an object won't rotate if the net torque, the sum of all of the torques around it are 0. And we're going to apply essentially that same principle here. So if I masses, because I think that helps explain a lot of things and makes the seesaw example a little bit more tangible. Let's say I have a 5 kilogram mass here, 5 kilogram, and let's just say that gravity is 10 meters per second squared, right? So what is the downward force here? What is the downward force? It's going to be the mass times the acceleration, so it's going to be 50 newtons. The moment arm distance, or the lever arm distance here, and let's say that this distance right here is 10 meters. And let's say that I have another mass. I don't know. Let's say it's a 25 kilogram. No, that's too much. Let's say it's 10 kilograms. Let's say I have a 10 kilogram mass. 10 kilogram mass. And I want to place it some distance d from the fulcrum or from the axis of rotation so that it completely balances this 5 kilogram mass. So how far from the axis of rotation do I put this 10 kilogram mass? This is the distance, right? Because we actually carry the distance to the center of the mass. Well, how much force is this 10 kilogram mass exerting downwards? Well, it's 10 kilograms times 10 meters per second squared. It's 100 newtons. So, this is acting what? This is acting clockwise, right? This one's acting clockwise, and this one's acting counterclockwise, right? So they are offsetting each other. So we could do it a couple of ways. We could say that 50 newtons, the moment in the counterclockwise direction, 50 newtons times 10 meters, in order for this thing to not rotate, has to be equal to the moment in the clockwise direction. And so the moment in the clockwise direction is equal to 100 newtons times some distance, let's call that d, 100 newtons times d. And then we could just solve for d, right? We get 50 times 10 is 500, 500 newton meters is equal to 100 newtons times d, that's 100. Divide both sides by 100, you get 5 meters is equal to d. So d is equal to 5. And that's interesting. And I think this kind of confirms your intuition from playing at the playground that you can put a heavier weight closer to the axis of rotation to offset a light weight that's further away. Or the other way to put it is you could put a light weight further away and you kind of get a mechanical advantage in terms of offsetting the heavier weight. So let's do a more difficult problem. I think the more problems we do here, the more sense everything will make. So let's say, let me